Now, over the years, mathematicians have created a lot of formulas and they put them in tables. So what I want to talk about now is this right here, where we're going to talk about integration from tables. So in this first example, I want to show you that there's a formula for u to the n times cosine of u du. And that formula is simply u to the n sine u minus n times the integral of u to the n minus 1 times sine u du. You also have a formula for u to the n sine u du, and that's minus u to the n cosine u plus n times the integral u to the n minus 1 times cosine u du. So we're going to apply those formulas in this problem. So here I have x cubed cosine x. So I'm going to use that first formula where u is x. So since u is x, then of course dx, du would simply be dx. And n is actually going to be 3 here. Okay, so take a look right here. So if I apply this formula up here, the first thing I'll apply is I'll have x to the n power, and since n is 3, then I'd have x cubed, and then I have times sine of u, which would be x, sine of x. And then minus n, which is 3, times the integral of x to the n minus 1. So if you subtract 1 from 3, you get 2, so it'd be x squared times sine x dx. Now, so I know now that I can write this as x cubed times sine x minus 3. And now let me go to up here for x squared sine x, and let's replace x squared sine x with what this equals. So here I would have u to the n sine u equals minus u to the n cosine u plus n times this integral. Alright, now remember, to solve for this integral here, remember for that one, the n is actually 2. So I'm going to leave the 3 on the outside here, and then I'm going to plug this in. So I'd have minus u to the n, so that'd be minus x squared, times cosine u, so that'd be cosine x, and then plus n, so that's 2, times the integral x to the n minus 1, so that would be just x to the first, times cosine u, so that'd be cosine x dx. And so now I'm going to bring this down right here, so x cubed sine x is here, and then if I distribute the minus 3 here, I get minus 3 times minus x squared, so that's going to be plus 3x squared cosine x. And then I also have to distribute the minus 3 times the integral, so I have minus 3 times 2, well that's minus 6 times x cosine x dx. So now I've got one more integral to deal with, and now this integral is actually x to the first power cosine x. So I go back to this first formula, and so the formula for this would be, let me go ahead and copy the terms over. So I copied the first and second terms over, then I have minus 6, which is there, and then I'm going to evaluate this integral. Okay, so if you evaluate this integral, it says it's x to the n, so that would just be x, times sine u, so it'd be times sine x, and then minus the integral x to the n minus 1. Okay, that would be x to the 0 in this case, because remember n is 1 now, so that would be x to the 0, so I would just have 1 for that term, but then I'd have times sine u du, so that would be just sine x dx. So now let's copy everything down and see what I've got. I've got the x cubed sine x there, I've got the 3x squared cosine x there, and then I'm going to distribute the minus 6 through the x sine x, so that's going to give me minus 6x sine x, and then I have to distribute the minus 6 through here. Minus times a minus is plus, so I have plus 6 sine x, and then just copy these 3 terms over here. There's 1, 2, 3 terms, and then go ahead and integrate the sine integral, and you know sine integrates to minus cosine, so you'll just get minus 6 times cosine x here for the last term, and then you're going to have your constant there at the end. So there's your final answer. It's got 1, 2, 3, 4 terms and then a constant. Okay, so here I have 1 over x squared, square root of 3 plus 4x. Okay, so now 4x squared, excuse me. So now I actually have u squared. I have u squared here, du over u squared times the square root of a squared plus u squared, and I've got an answer for this. Okay, so let's see if I can make this fit that form. Okay, so if this is going to be u squared, then u would have to be 2x, right? Okay, so I want this to be a squared plus u squared. Well, for this to be a squared, a would have to be the square root of 3, therefore a squared would be 3. And then for 4x squared to be u squared, then u would have to be 2x. And if u is 2x, then du would be 2dx. Okay, so but what I'm going to do here is, for this formula here to work, I've actually got to have the same thing here and here. So first thing I'm going to do is go ahead and multiply the top and bottom by 4. Now I've got u squared outside the integral, and in the integral I've got my a squared plus u squared. Okay, now the problem though, remember I said if u is 2x, du would have to be 2dx. So what I can do to make that work, I've got 4dx. So what I'm going to do is I'm just going to factor a 2 out of this 4 and pull it out of the integral. So now I have it. The 2dx is the du. This is 2x quantity squared, so that's u squared. And this is the square root of 3 squared plus 2x quantity squared. So this is a squared plus u squared. So now I have it in the proper form, du over u squared plus the square root of 3 plus u squared. And the formula says that that's actually equal to minus, now the 2's here because I had a 2 that has to be carried along. So that 2's there for that reason. And then I have the square root of a squared plus u squared. A squared is 3. And then I'm going to go ahead and put u squared here, and then I'll switch it out in a minute. And then on the bottom, I have a squared u. Remember, a squared is 3, so I put 3 there, and then u. Okay, now let's go ahead and replace u with 4x squared. So once we replace u squared with 4x squared, then we'll get minus 2 times the square root of 3 plus 4x squared, and then 3 times u, which is just 2x. And then finally, notice that this 2 here will cancel with the 2 in the denominator. So if I cancel those 2's, then I'm just going to get minus this square root over 3 times x. So I get minus that square root over 3x, and then plus a constant. Now what I'm going to do first here is I'm going to actually eventually let u equal cosine x, so that du is minus sine x dx, and then I'm going to use a formula. But let me show you what I need to do first. First thing I need to do is let's write sine 2x as 2 sine x cosine x. Okay, and then what I can do then is I can take the sine x and put it with the dx to kind of get it out of the way. But remember, if I let u equal cosine x, du is minus sine x. So what I'm going to need to do here is I'm going to need to multiply the inside by a negative, so I get minus sine, and then the outside by a negative. Okay, now let me show you what happens here. So that gives me a negative on the outside, also pull the 2 out. And then over here I put the sine x with the dx and also the negative. So now this minus sine x dx right here is simply du. And now this is u on top over square root of a constant plus 5u. So now I have minus 2 over u plus the square root of 3 plus 5u du. And so now I have this formula here that actually says if I have u over the square root of a plus bu, then that integrates to this formula. Okay, so let's see if I can make this work. I just copied the integral right here. Okay, so the formula would be 2 over 3 times b squared. Now b is the coefficient of the u, so that'd be 5. So it'd be 2 over 3 times 5 squared. So that would be 2 over 3 times 25, which is 2 over 75. And of course the negative 2 came from in front of the radical. And then what else do I have? Then I have BU minus 2A. Well, B is 5, so I have 5U, and A is 3, so I have minus 2 times 3, so that's minus 6. So I get 5U minus 6. And then I have this square root of A plus BU, which is simply the 3 plus 5U. Okay, so there's your answer. Now, I can simplify this a little bit. Negative 2 times 2 over 75 is negative 4 over 75. And that's pretty much all I can do now. Now, the last step, and I just copied this down here. So the last step, I'm going to replace U. Remember what I used for U in the substitution earlier? It was cosine X. So everywhere there's a U, I'm going to put in a cosine X. So where 5U minus 6 will become 5 cosine X minus 6. And 3 plus 5U will become 3 plus 5 cosine X. And then finally, I get the final result from that table. Okay, I'm just going to do a couple more of these. Okay, so take a look at this one. And on this one, there's actually a formula for x to the ax plus b to the negative 1. So here the a would be 2, the 5 would be b. And so I would just write it as the answer is x over a, so it's going to be x over 2 minus 5 over a squared, so minus 5 over 2 squared, so that's minus 5/4. And then the natural log of the absolute value of ax plus b, and ax plus b is just 2x plus 5, so I'll write that natural log and then add my constant. Okay, here's another one. This formula, dx over x times square root of 2x plus 4, would actually follow this formula for the integral of dx over x times the square root of ax plus b. Okay, now here my a is 2 and my b is 4. So if I use this formula, I'd have 1 over square root of 4, which is just a half, and then times the natural log of the square root of ax plus b here minus the square root of b, so that'd be square root of 4, which is 2, and then all over the square root of ax plus b plus the square root of b, which would be, again, 2, and then plus a constant. So there's your answer for that one. And now look at the next one here. On this one I have, it looks very similar to this one, except I have a minus 4. So on this one, dx over x times the square root of ax minus b, it's going to be 2 over the square root of b, so that would be 2 over square root of 4, which is 2 over 2, and then times the arctan of the square root of ax minus b, which is 2x minus 4, all over b, which is 4, because remember a is 2, b is 4, and then plus the constant. And the last step, I just took this, let's see, I just factored a 2 out of the numerator here and divided it into the 4. So you can actually factor a 2 out of the numerator and cancel it into 4, and that way you get 2 in the denominator there. And of course 2 over 2 was 1, so that just disappeared. Alright, so there's that formula, and there's the formula I used right there, just didn't have it highlighted. Okay, I'll wrap this up. There's a couple of reduction formulas here. So here's a reduction formula for tan n of x dx, and I'll let you read the formula, and I'll just do this example real quick. Tangent to the fifth x dx, it'd be 1 over n minus 1, so n is 5, so you'd 1/4 of tangent to the n minus 1x, so tangent fourth x, and then minus tangent to the 5 minus 2, which would be tangent cubed x dx. Well, so you're going to get 1/4 tangent fourth x minus, okay, and now for this, you're going to use the reduction formula again for tangent cubed. So if you use the reduction formula again, this time n would be 3, so you'd have 1 over 3 minus 1 times tangent to the 3 minus 1, 2x, and then minus the integral of tangent x. And then distribute your minus, and you're going to have this term minus this term, and now you have plus tangent x. So now we actually have a formula for integrating tangent x dx, and that's actually minus the natural log of the absolute value of x plus a constant. So if you put those terms together, you get your final answer. And so basically I just had to keep using this formula till I got tangent, the power of tangent, reduced down to something that I could deal with without having another integral to deal with. Okay, and here's an example here. Here's an example here that you can work on, and there's the formula. That's all I have for these types of problems.